Okay. So I'd like to talk to you today about the ecosystemic approach of marine energies by modeling the way it is modifying the functioning of the coastal food web. So when I arrived in Normandy, it was in 2012, and we saw with my colleague François Leloc from Lemar that there was a strong demand of the society to understand how those new projects would react and interact with the marine ecosystem. So we led a reflection on how to modify the tools, the numerical tools for modeling the food webs, coming from the ecosystemic approach of fisheries, how we could adapt them to the marine energies. And this led to the project called Trophic. But Trophic was just the first one of a series of 3 projects financed through France Énergie Marine and with the colleagues from Lemar, but also from Vimereux, the University Littoral Côte d'Opale, and from France Énergie Marine, and together with industries and Parc éolien en mer du Calvados for the Courseulles site, which was the subject of our first project, Trophic. So Trophic had 2 other projects following, Appeal, which is going on now, where the modeling of the ecosystem is still there, but also much developed towards sociology and social ecosystem modeling. And today, we also have Windsurf, which is developing the aspect on ecosystem services and connection with dynamic models, physical models. So the Trophic project finished in 2019. You have here the consortium, but we were also highly connected to a whole set of collaborators who participated to the debates we organized or to the science. For example, with CSIRO from Australia, who had a great help for modeling, for example. Those different persons were involved in developing tools for modeling the food web. So the food web is composed of intricate food chains like this, and we develop models where we try to quantify all the flows between all the trophic compartments in a system. So this is our model where we often work with more or less 40 trophic groups, and I must say that it's not a perfect model. The microbial items are still not very precisely modeled, but for the macrofauna and the different sources of production, the phytoplankton, the detritus, this is not too bad, I would say. So to quantify all those flows in our models, we use the method called EcoPath, which is a static snapshot which quantifies this static snapshot of the system. But this EcoPath method is also developed into Ecosim, where you can project this in time and quantify it year after year, and Ecospace, where you go into a grid, a map of a zone, as we did for the Bay of Seine, and then you have one food web and one dynamic model of the food web within each little point of this grid. And from those models, we derive what we call ENA indicators, which is for ecological network analysis indicators. And I will give you a few examples. It is a very long list of indicators describing the functioning of the food web. Here, for example, we illustrate the mean trophic level, which is a quantification of the trophic levels of every species in your ecosystem from scientific campaigns, and you calculate the average trophic level weighted by the mass of each species. This is important. This indicator, we propose it to OSPAR as a Marine Strategy Framework Directive indicator for good ecological status. It is used by the French government, but also by Spain and Portugal. And this indicator, for example, is important to characterize the ecosystem health, because we know that the fishing, overfishing often makes a pressure that is shortening the food chains, and so this trophic level is going down, for example. But ENA indices are very numerous. You can quantify how detritivory is important compared to herbivory, how recycling is important, omnivory, the transfer efficiency between the different trophic levels, or redundancy of the flows, for example. So all these indicators are potential ecosystem health indicators, but their main objective is to describe the ecosystem functioning in relation to maturation processes, but also to stability, resilience, etc. So it gives an important view of the food web. So we applied this modeling and analysis tools to the two situations in the Bay of Seine. One was a zero-dimension model on the Courseulles-sur-Mer site that Nicolas just presented before. And the second modeling, so for this we used the EcoPass model. So it was a static model for 1 linear in the park, in the offshore wind farm, with the 64 monopile turbine there. And we modeled the reef effect and the reserve effect. So the reserve effect here is very limited, because most of the zone will be open to fishermen, but the reef effect was quite important, with massive settling of mussels and a lot of different associated species. So we can say that punctually on the zone, we have a strong reef effect, defining a new system not characterized quite far from the system around the farm, where there is sand and gravels. And here we have a solid structure with rocky species, defining this new system where detritivory is very important because of the presence of those bivalves mussels filtering the water and this detritus. What we also showed from those models, that you can find in all the papers derived from the PhD of Aurora Hooks, is that the development of such a biomass around the monopiles will also cascade up to top predators. So with the potential for attracting, on the food availability point of view, top predators. Of course, this has to be balanced with the fact that there may be also more boat moving or noise, and all these questions must be balanced with what will really be observed. But on the trophic point of view, we may have this cascade, quite interesting for conservation questions. Then we modeled a second model, a second point of view, with a two-dimension modeling. So here you have the map of the extended Bay of Seine that we model. So this means that every 1.6 kilometers you have a new grid, here a new point in the grid, and the model is in fact running in all those points of the grid. And from this, we developed methods with all the postdocs involved in the Trophic project, methods for quantifying those ENA indices in every point of the grid. And we developed also scenarios. We still are developing the reef scenario, the reef effect scenario, but the first scenarios were about the reserve effect, and this is the object of the paper by Hassan Halwani that just was published a few weeks ago. So what we show here is that with what is scheduled, with only a little part of the zone close to fishing, we don't really see effects on the reserve effect point of view, the closer to fisheries. But if we make a sensitivity analysis out of it with a what-if scenario where all the zone is closed, then we can observe a spillover effect that could mitigate part of the negative impact for fishermen with this reduction of the fishing zone. So this is in the hypothesis of the total closure for doing our simulation, and that this spillover means that you have an increase, a potential increase of the catches around the zone, with up to 7% of increase, and also an increased proportion of high trophic level species, which are the ones which are commercially interesting. So this has to be driven more, but it can be interesting for the discussion with fishermen to have this spillover effect in mind, even if it is quite reduced in space, and with the spillover zone quite limited in this space. And then we also worked on combining effect between not only the presence of the wind farm, but also questions related to fisheries, aggregate extraction, etc. But the main development we did was the taking into account of climate change effects to combine them with the presence of the wind farm. So for this, we developed some new methods together with Tarek Attab and Frida Benrais-Lasram and Boris Leroy, also from. So our different colleagues developed new methods and niche modeling methods, but with new attributes, to have simulations of how the probability of presence of the main species in the food web would be modified according to IPCC scenarios for a 50-year simulation. And from those new distributions, we modified the ecospace model, the spatial model, to see how this will change the ecosystem attributes, the ecosystem functioning, and see the cumulative impact. So all these are still ongoing work. This is part of the PhD of Quentin Noguès, who is financed by Région Normandie. And the main idea here is to finally analyze those how those different pressure interact. For example, if I take one DNA indicator, for example, here I can say I quantify recycling, for example, then you can say that you have one effect, like for the reef effect, and another effect, like, for example, the climate change effect. And then if the sum of the effects is equal to the combined effect when you model them together into your food web, then you say that it is additive. The cumulated effect is additive. But then if it is lower, you say it is dampened. And if it is more, you say it is synergetic. So all those questions now are being worked on in a context which is larger to the one from the Trophic project. So work ongoing in the PhD of Quentin. And he is working on taking into account not only the reserve effect of the farm, but also the reef effect, not only the climate change and the distribution of species, but also physiological changes. And also we are working on aggregate extraction effects, fishing scenarios of changes linked, for example, with the Brexit negotiation, etc. So from all this, we can compare the present time model with single drivers models and with cumulative models, and see how those cumulative effects are in interaction and study synergies. So from all that, we derived a series of recommendations that you can find in the France Énergie Marine documents that were, the first author is Emma Arrhenius, that we widely try to propagate it everywhere, so that everybody could have those main ideas that we derived from the Trophic project. Those are mainly methodological recommendations and about what to do with the present time offshore wind farms being built, but also recommendation for future offshore and energy devices. So the ideas are here, it's important to have the whole ecosystem taken into account into the modeling, but also into the monitoring, because we need data for the modeling, like diet data, production data, not only biomass and species present. It's also important to have some ideas from the what is eaten from stomach contents or isotope analysis, as in the methods we advise for the French government, for the MSFD, good environmental status, for example. And it's also important to go into those coupling of models. This is what we are trying to do now in the WindSurf project with hydrodynamic models, in order to have a nice view of the low trophic level, which is quite a little bit neglected in what I showed here, and also going further into this integration of the climate change effect into those models and in social ecosystem modeling. And from that, we can go further into this ecosystem-based management. This ecosystem-based management, we talk about it a lot in fishery science, but it's very important also to enlarge it to all effects, including marine energies, but also cumulated with all other human activities. And I thank you for your attention. You have here the different publication I've talked about, but don't hesitate to send me an email if you want me to send them to you. That would be the best way. Thank you.